Well, I have been already introduced, but I want to introduce that one over there, which is my dog, Bacata. And I'm introducing her because she always gets all the attention while I present. So just to let you know who is that one that is always the beloved one during my talks. So I am here to introduce you to Amazon Braket, our fully managed quantum computing service on AWS Cloud. And I hope you will be using it a lot during the Open Hack. So I will show you the console. I will do a demonstration so that you get to know what you can get from the service and you start getting familiarized with it. So our service will allow you to cover all, let's say, the life cycle while you are developing applications for quantum machines. So the functionality is grouped in these 4 parts that I am showing here in the screen. The first one is you will be able to start building your code using Braket SDK. And as I will show you later, through Braket, we are providing access to different types of quantum machines, different hardware. And with just using this single SDK, you will be able to start generating or creating your circuits for all those different types of quantum machines. That SDK can be installed locally on your laptop, on your PC, so you can start working there if you want to do so. But you can also use Jupyter notebooks, managed instances that will be living on AWS Cloud, and you will be accessing them through the Braket console. And you can use them if, for some reason, you want to have more resources on that machine you are developing your code, or maybe because it would be easier to collaborate with other people that will be working on your project. And that is the first part, building your code. Then you will want to test it. And for that, we're offering different types of simulators. And I will talk about them in a few minutes. But the thing is that before going right away to the actual quantum processing units or QPUs, the quantum machines, you can refine your code using the simulators. And this is really cost effective when you are using the service. So you can optimize your cost by preparing your circuits on the simulators. And after you are ready, start running your experiments on the real QPUs, which is actually the next part you see there on the slide. So that is the heart, let's say, of Amazon Braket, offering you different types of QPUs so that you can run your experiments using real quantum machines. And I will also mention the different options we have here so that you can access hardware from different vendors through a single pane of glass. And finally, Braket is part of the AWS ecosystem. So it is integrated with other services. For example, Simple Storage Service, or S3, our object-oriented storage service, is used to keep the results of the execution of your circuits. That is one example of the many services that can be integrated with Braket. But this last part, which is called Analyze, is related to the monitoring. So you can monitor your task, you can monitor how your algorithms are running on the QPUs and use that information for different purposes. So that is like the 4 parts in which we group the functionality of Amazon Braket. And how is all of this happening? Well, Amazon Braket offers different pieces. Let's say that inside the service, its architecture is composed of various pieces. So we have the different ways in which we can access the service. I already mentioned you can install the SDK on your PC, on your laptop, but you can also use managed Jupyter notebooks, which are already provisioned with everything that you need to work with Amazon Braket. And obviously, you can use the AWS console. I will show it in a while so that you can know how you can navigate into Braket and what you will find there. Then, of course, you have the SDK, which will allow you to generate your circuits, start creating your algorithms, and then leverage what, again, I call the heart of the service, which are managed simulators and the different types of QPUs. And here you can see we're already mentioning the different architectures that we offer, but I will go back to that in a few more slides. Okay, so regarding the simulators, we're offering four different types. The first one is, well, the local simulator that, as I said, can be installed on your own laptop. You can start working there. And that local simulator, you actually locally can use the state vector simulator, which I will mention in a while, and the density matrix simulator. But if you are running those locally, you will have a little bit less qubits available for your simulations than what you have while using the managed simulator. So I will share later in Discord the link. Actually, in this presentation, you will have the link to the getting started documentation for the service. And there you will be able to find the quotas that we have for the service, including the amount of qubits that you have available for each simulator and for each QPU. But even though through Discord, I will share the direct link to those quotas so you have them in mind while we are using the service. For the local simulator, for example, if you use the local state vector simulator in your laptop, you will be able to simulate up to 25 qubits in your circuit, in your qubit array. So just take that, keep that in mind. Is something that, depending on the kind of experiment or the type of algorithm you're generating, it can be something that affects you, and then you would like to jump into the managed simulators that we have available in the cloud. So those managed simulators are these three that we are mentioning here. The first one is the state vector simulator. If you use it on the AWS cloud, you will have up to 34 qubits to run your circuits available there. And the characteristic that the state vector simulator offers is you can store the full wave function state of your circuit. You will have to pass certain parameters to do so, but you can actually have that instead of just having the count of the different results that you get from your circuit. You can have the full wave function state. The tensor network simulator, the characteristic it offers, well, there you have up to 50 qubits for your simulation. And the characteristic it offers, it represents the circuit as a graph. So the qubits and the gates that you apply in your circuit are represented as nodes. And the way this simulator works is it will try to find optimal ways to execute your circuit. This is really useful if you have local gates applied in your circuit, so that gates that are being applied on a subset of the full qubit array that you have in your circuit. Because when you have circuits with those characteristics, this simulator is able to, let's say, compress the circuit while in execution. So it is very good to optimize execution for this type of circuits. And finally, the density matrix simulator, which allows you to start introducing noise while executing your simulations. And this is really useful because you will have noise when you use QPUs, and you can start refining your code and introducing error correction mechanisms there before going to the actual QPUs. So those are the simulators. And then, as I said, we have different type of QPUs. Currently, we're offering 5 different types of QPUs from all these different vendors, which are our partners. And here you will have different architectures and different programming models for these QPUs. So, for example, Rigetti and OQC offer superconducting QPUs, a superconducting based QPU. IonQ is based on ion traps. Xanadu, for example, Borealis uses pulses of light. And finally, QEra uses Rydberg atoms. And for the programming models, where the first 3 you can use gates to program your circuit. Xanadu is oriented to, I forget the name, sorry. QEra will use analog Hamiltonian simulation, I'm sorry. And Xanadu, boson sampling. Okay, so I'm sorry for jumping as that into, but I forgot the name. Okay, so that are the different QPUs, the different architectures, and the different programming models you will have available through Amazon Braket. And well, so I think we're ready to jump right into our demonstration, so you can take a look on the console and on everything we offer as already explained during the presentation. So let's go back here. Let's go here. And well, this is the AWS console. If you want to access Braket, of course, I have it here in my recently visited because I use it a lot. But you can access it if you don't have it there because this is the first time you're using it. From the menu services, you could go to Quantum Technologies, and there you will find Amazon Braket. But you can also use a search bar and just type the name, and you will be able to get into the service. And in order to use the service, you have to complete some getting started steps, let's say, which we will be guiding you through them on one of our office hour sessions. I will announce that a little bit later. So this is the dashboard is an overview of the service. What I want to mention is if you get to start use the service as a regular user, just be aware of the announcements because we are always releasing new features, and we also are looking to add more and more QPUs to our offer. So there is where you will find our news and everything that will be coming. Okay, so if we go here to devices, you will find the list of the available simulators and QPUs that we have through Braket. And in order to run your circuits, I want to point out a couple of things. So for example, if you get into the details, let's get into the details of the Rigetti QPU. First of all, you will see that all of them have an availability window that is announced here. If you see they are available now, it means that they are up online, so that to attend the task queue that is being created every time you or other users send a task to the QPU. If they have this message specifying a time in which they will become online again. So they are not available now. They will become online in 2 days and 17 hours. But you can still send tasks to Lucy, to OQC, for example. The only thing is that it will remain in a pending state until the quantum machine is online again, and then it starts processing the task queue that gets formed when you are sending your task, okay? So just something to take in consideration. Let's go into the details of Rigetti, and there are certain things that you have to watch out while using the QPUs. First of all, the AWS resource name, which is this one, which will be used in your code to specify where you want to run your circuit. So there is where you will find it. And the other thing is, all of the QPUs are associated to a certain AWS region. That is important because when you send a task and then you go here to check the results from the console, you will need to make sure you are in the right region, depending on which region is the QPU associated to. Okay, so just remember that. And you will find other details regarding the QPU that depends on the different vendor, the information you will find here, okay? Now, if you want to use the managed notebooks and take advantage of these instances that are managed for you, but that they provide everything that you need to develop your code for Braket, you will do so in this menu. You can create here as many instances as you want. Of course, the usage of these instances generates a cost. Just take that in mind, especially when you're using your credits for the Open Hack. And you can stop your machines whenever you want. That stops the consumption being invoicing, you know, so when they are stopped, they are not generating a cost. Just take that also in consideration, because maybe for the times you are not working on the Jupyter instance, you would like to maintain it stopped and then restart it again when you are ready to continue working. So I will go into one of them, and you will see there what you will find that they are all preloaded with some examples of code, so that it makes it easier for you to start working with Braket. And I will just point out a few things here because we have limited time, so that hopefully this makes it easier for you when you start working with these examples. As you see, we have different folders because in each folder you will find different types of materials. I will visit here the getting started, the PennyLane, and the hybrid jobs just to, again, point a few things out. So the getting started, let's go into this running on QPU devices notebook. You will find there how to run your circuits on actual QPUs. So obviously it starts loading some libraries from Braket. Then as you see, you can ask for the different gates that are supported by each of the QPUs. That is something just to show you that there are different sets of gates supported by each QPU. And then generating a circuit is as simple as using the circuit class and then start adding your gates. So since this example is a bell state, you just need to add a Hadamard gate on qubit 0 of your array, and then a control node that will use the qubit 0 as a control and a qubit 1 as a target. So that is, it is simple as that to define your circuit. And then in order to run it, you will need to specify a device. The first part of this example is using the local simulator. So this circuit will be run in this Jupyter notebook using the simulator that is included on Braket SDK. And let me zoom in if I found it. Oh my God. Oh, there it is. Okay. So hope that looks. And so in order to run it, once you define the device, you just do the device.run, you pass your circuit and the number of shots you want to run. So that is as simple as that. If you want to run this same circuit on a QPU, you just need to define your device by passing to the AWS device class, passing the ARN for the target QPU. Okay, so it's as simple as that. Your circuit is still the same. And then you just do the device.run again, and you are running your circuit on the QPU. It's as simple as that. So for this example, I just want to point out that. Let's go back to the PennyLane examples. And here I will go to this BQ example, the variational quantum eigensolver. And so it is really easy. Well, PennyLane makes it so easy to start running simulations. For example, here we're calculating the energy of a molecule, and PennyLane makes it so easy because they have this QChem library that has a lot of things already defined for us. So for example, here in order to run the simulations and calculating the energy of the molecule, we don't have to define the Hamiltonian by ourselves, because the QChem package can already provide that for us for certain molecules, of course. And so we just run this molecular Hamiltonian, and we are going to get the Hamiltonian and the number of qubits that we need to run our simulation. It is as simple as that using PennyLane. It has other properties that we can get for our molecule, for example, the total spin. So that is also inside this QChem library. And for example, if you want to complete the Hamiltonian with other terms in order to have more precision on the results. In this example, we are using, we're preparing an ansatz that consists of the Hartree-Fock state, which is we can get also from the QChem library, and adding the single and double excitations for our molecule, which again we can get from the QChem package. So this makes it really easy to prepare our algorithm in order to start running it on the quantum machine. And then while using PennyLane, you will need to specify your device in this way that you will find in the example. And the important thing is for a variational quantum eigensolver, you will run a cycle that will be executing. A part of the execution will happen on a classical processing unit, and part of it will happen on a QPU. And in this example, we're just running everything on our managed notebook, and it will send the quantum part either to a simulator or to a QPU. But this actually can be executed by using a function that Braket provides that is called hybrid jobs. So every time you would benefit of combining classical and quantum, you can take advantage of this hybrid jobs function that we provide for Braket. So I will go to the jobs part here in the console to show you how easy it is to generate a hybrid job and then take advantage of this kind of differential programming approach and combine classical with quantum. So it is as easy as you click create job here. The classical part will run on a container, but you don't have to worry about it because when you create your job through Braket, everything will happen behind the scenes through Braket. So we solve that for you, AWS solved that for you, and you don't have to worry about it. You will put there a name for your job. You will load here the file for your algorithm. So for example, I have here one algorithm that is actually part of the getting started materials that you will find in the Amazon Braket examples. And well, actually it is in the hybrid jobs folder, but you will find the example there. And here you will choose the container that will execute the classical part. So you can use the basic one. It depends on the characteristics of your algorithm, but we already have some containers, including PennyLane libraries. So you can take advantage of this. And you can use your own container. You can create your own container with the characteristics that you need and upload it. In Braket's documentation, you will find how to do it. And here you will pick the QPU or the simulator where you want to run the quantum part. Okay, so it is as easy as that. Everything else will happen behind the scenes for you. And then you will just need to go back here to the console to see how your job is executing, what's the status, what are the different tasks that are being sent to the simulators or the QPUs, and keep track of what is happening with your hybrid job. Okay, so having said that, I know it is really fast here, but we have limited time for this session, and I want to give you some announcements that are relevant for the upcoming Open Hack. So let me go back to the presentation. So how to get started with this? First of all, I want to share with you these resources. First one is Braket documentation. You will find everything that I mentioned here about how to create hybrid jobs, what are the quotas and the amount of qubits available for each QPU, for each simulator. Everything will be there. And either way, I will be sharing relevant information on Discord, so keep aware of that. And the second one is the GitHub repository where you will find Braket examples. You can still find them in the Jupyter notebooks, as I showed. They are already preloaded there, but you can access them directly here from GitHub, and you can use all of this code as a base for whatever you will develop during the hack. So that is available and it is open for you to use. I want to mention the free tier. So during the QHack, you can be awarded for credits to use on AWS Braket. But let's say you want to continue using Braket. During the first year after you activated Braket, you will have access to our free tier, which includes 1 free hour of simulation time per month. So during the first year of using Braket, you can use simulators for free during 1 hour each month. Keep that in mind. Even during the hack, you can take advantage of this and make a better use of your credits to actually run your circuits on the QPUs. Just take that in mind. And for the Open Hackathon, so there are big prizes. As you know, there will be phases. So for first one, which is the coding challenge that will be delivered by February 21st at 5 p.m. The top 50 teams that complete the coding challenge will receive $500, 500 USD in AWS credits, okay? It is important, if you are awarded this, if your team is awarded with this, you have to request the credits. If you don't request them, you might lose them. So be aware of that. And be careful. If you're awarded them, be sure you request your credits. You will receive instructions on how to do that. Second phase, so the projects that will be judged on February 23rd, top 10 projects in that phase will be eligible to receive $2,000 in credits to continue working on your project and complete it by February the 28th. And after February 28th, the top 3 teams in this Open Quantum Hackathon might receive $10,000 in AWS credits. So these are big prizes. Hope you are all participating with us during the Open Hackathon, and keep in mind you will be awarded credits for your participation. We will have office hours so that you can ask your questions and you can get to use Amazon. The first session of this office hours that will happen on February 22nd, 9:30 a.m. will be an onboarding walkthrough so that you can, I already show you Braket enabled and working, but you have to complete certain steps to do that and generate certain roles and things to make it work. So participate in these office hours. You will be guided here by one of our specialists so that you get Braket up and running and you are ready to start coding there. And for the rest of the hack, we will have daily office hours so you can ask your questions. The daily sessions will happen during the morning. So keep in mind that from February 23rd to the 27th at 9 a.m. Eastern Time, daily, you will be able to connect with us and ask your questions. During the afternoon, the sessions will not be happening daily. Keep that in mind. So there will be just 2 sessions during the afternoons. It will be the 23rd and the 27th at 2 p.m. East. So those are not daily. Just keep that in mind. The morning sessions are daily from the 23rd to the 27th. Okay? And so those are the announcements, and I hope all of you will be participating with us during the Open Hackathon. Well, I think we are right on time and ready to open for the Q&A session.
Thank you so much, Vanessa. That was really informative. And we had a really active chat going on as well. I can see on Twitch here, lots of questions that came through. I know a lot of them got answered by other Amazon folks in the chat, which is really helpful. Before we get to any other questions from the audience, and this is your moment for asking any extra questions you want to ask to Vanessa in particular, folks. Before we get there, I wanted to ask you about the Guinness World Records. I hear you've been involved.
Yeah, that is a funny fact about me. I participated in breaking 2 Guinness World Records. Not just myself, but during my childhood, I was a Girl Scout, and we participated in this challenge to create the fleur-de-lis, the largest fleur-de-lis in the world, which we did in Zocalo, which is downtown Mexico City, with cans, soda cans, and we created the largest fleur-de-lis in the world at that time when I was a child. And then, prior to join AWS, which I'm really proud of, I was working for IBM, which I am also so proud of. And there we participated in this event to deliver the largest software workshop in the world at that time. And we won, and we were able to break that World Guinness record. I think it was 2017 or 18. So those are my that is my fun fact.
That's actually quite amazing. So how many people were at the largest software lesson ever?
Well, it's really fun because it is not only that you have a certain amount of participants during the session. You have to make sure all of them are working on the workshop and all of them get the final result that a workshop is intended to get. So, and there are judges going around and checking that nobody is distracted, checking your phones. So we have a lot of collaborators there. I was part of that team, checking that everyone was working, that they don't have issues while executing the exercise, and that everyone and they forget about their phones. So you might know that with because this was delivered to very young people, in an event at Guadalajara in Mexico. So it is really challenging to avoid them to get distracted by messages and things like that. So, but it was fun.
I can only imagine. Yeah. So we did have a couple of questions also from the chat here. So Freemason Magic wanted to know, are the quantum are the quantum web servers based on the Apache web server for Linux?
Oh, well, no. The web, I mean, you might be talking about the servers we use for simulators. So there, in Braket, we are using classical servers. One for the Jupyter notebooks, which are just EC2 instances that come pre-installed with Jupyter, with the Braket SDK, with Docker, because if you run hybrid jobs there, you will need to execute a container there. And those are EC2 virtual machines that come prepackaged with all of that. No Apache there, but it's a classical EC2 virtual machine. And of course, the simulators are also classical machines. We're not using any kind of Apache there, but they are clusters of classical machines that allow you to run your simulations. And those clusters are completely managed by AWS, so you don't have to worry about it. No Apache, at least in Braket, in the classical parts that we include in Braket. Okay.
Awesome. Yeah. Okay. That's helpful. We also had a question about the office hours from Quantum Catalina, which is, where are they happening? Where would we find them?
Okay, so as far as I know, you will be finding them in the QHack agenda. So as the same way you are accessing these streams, as far as I know, you will be accessing also the office hours. I will double check that for you and let you know through Discord, but that is the information that I have.
Awesome. Yeah, I can imagine they might actually be in Discord. And you're going to be there after this talk to answer any questions as well, correct?
That's right. I will be participating in Discord with you and sharing you all the links. So I already shared with you the main resources in that slide with the QR codes, but I can share direct links to some of the information that I mentioned during the talk. For example, the quotas, so that you are aware of how to use each of the simulators and the QPUs.
Yeah, that sounds great. It's really helpful to have so many resources and ways to get involved here. One final personal question, which was from Mystic Fear. How did you get into quantum?
Well, I think that the best things in my life had happened for a curious reason that I wasn't planning. So I was part of this top technical talent team in IBM back in the year. And I was sent to a special event that we were having in one of the main research centers that they have in New York. And just because we were all technical, they decided to present a talk about quantum computing. And I got in love with it. So I didn't understand everything, but I got in love with it. So I came back to Mexico and I talked to the CTO, telling him that I wanted to start learning about quantum. And then I learned that we had this quantum ambassadors team, and I said I want to join that. And that is how my journey started. So I don't have a background in physics. I'm an engineer, but I don't have a background in physics. And I have to study a lot to learn what I think I know now. And every time I am exploring new topics, I have to go back and recheck some information. But I love it. I love that I am challenged to to keep studying to learn about this emerging technology that I am convinced it will add value for us, for the humanity in a few years. And well, that is why I'm a quantum computing enthusiast, and I hope I am transmitting and sharing my enthusiasm with you, because I think this is really an amazing topic.
Well, yeah, you're definitely transmitting your enthusiasm. It's been really lovely to hear. Our other host, Catalina, who has been on during this week, is also an engineer by background and also worked at IBM. So interesting sort of connections there. There's a lot of engineers now in the quantum world, which is fantastic. Yeah. So thank you so much for being here with us today. Before you go, I'm going to confirm a few things that people should know, because the AWS power-ups are awesome, and yeah, people should make sure to fill in the power-ups form in order to be eligible. This has to be done before the end of the coding challenges. So if you're listening, go ahead and fill that in. We'll put it in the chat for you, so you can just follow the link straight there. And of course, come and hang out with the AWS folks in the Discord channel, the Discord server shortly, and for office hours later. So everything should be there. Also, check out the jobs that are available on QHack.ai. There's some interesting roles that are coming up there too. So definitely worth having a look at. And that is everything for now with Vanessa. Thank you so much, Vanessa, for being with us. It's been wonderful to have you.
Thank you again. I continue to be thrilled of being part of QHack, and hope you join us for the Open Hackathon and get those credits and enjoy working with Braket.
Thank you so much.